Sanibonani, Dumelani, Abusheni, Molweni. Greetings to you all. Welcome back. Today we will be doing Newton's second law in terms of momentum. We will also do the impulse and also do the impulse momentum theorem. So let us start.
Let us start. We will now be doing Newton's second law expressed in terms of momentum. Okay. Now, what is Newton's second law in terms of momentum? The definition of it is the net force exerted on an object is equal to the rate of change of momentum. Okay. So in symbols, that will be the F net is equal to the change in momentum over the change in time, where F net is what? F net is the net force measured in what? Measured in newtons. Okay. Now the change in P is the change in momentum of an object. It is measured in kilograms meters per second, where change in time is the time interval over which momentum of an object changes. It is measured in seconds. Okay. Now let us see how this this formula came about. Okay. So from Newton's second law, what do we have? From Newton's second law, we have F net is equals to ma. Okay, F net is equals to ma, but we know that a is equal to what? A is equal to the change in velocity over change in time. The change in velocity over change in time. Okay, so this is what? This is acceleration. So we substitute A is equals to Vf minus Vi over change in time into what? Into, let us say this one is what? It's equation 1. Okay, into equation 1, which is Newton's second law of motion. Okay, now if we take this A and we substitute it there. Okay, if we take this A and we substitute into equation 1, we're gonna have therefore F net is equals to m into Vf minus Vi over change in time. Okay, what is this? This is going to be F net is equals to m into Vf minus Vi change in time. Okay, change in time. Therefore, what do we have on top there? Therefore, F net is going to be equal to what? F net is going to be equal to, what is that? That is change in momentum. That is change in momentum over change in time. Therefore, this is going to be what? This is going to be Newton's second law in terms of momentum. This is Newton's second law in terms of what? In terms of momentum. Okay. So you are not going to be asked to derive this formula. Okay. I was just showing you how this formula came about, just for interest sake. Now there are many examples of application of this relationship. The relationship is the one for Newton's second law in terms of momentum, of which the following is not real. Okay, in this case we used 2 examples, of which the following 2 are typical. Okay, now we can have a bowler bowls a cricket ball and the batsman hits it straight over his head, the ball has a certain velocity after the bowler has bowled it. The bat exerts a force on the ball and thus changes momentum of the ball. Okay, since we know that an object that is moving has got a momentum. Okay, now if there's a force that is exerted on that object, it will obviously change its velocity, and when velocity changes, the momentum will also change. So in this case, a cricket ball is bowled and the batsman hits it, so the batsman will obviously exert a force on that ball. And the second one, we can have a nail is stationary on a piece of wood. A hammer exerts a force on it and it changes its momentum. Okay, because initially it was stationary, so when the force applied by a hammer, it means the nail will start to move inside the wood. Okay, now let us do example 1. For example 1, what do we have? We have a car of mass 1100 kg is moving eastwards at 20 meters per second. A car of mass 1100 kg is moving eastwards at 20 meters per second. Its driver applies the brakes to slow it down. The brakes apply a retarding force of 600 newtons and the change in velocity occurs over time. Okay, the change in velocity occurs over time interval of 12 seconds. Calculate the change in momentum. Okay, now how do we go about this one? Okay, we are asked to calculate what the change in momentum. So what do we have? Okay, we are going to we would first indicate the direction, and we're gonna say this is east, this is west. We take this one to be positive and the other one is going to be negative. Okay, west. Now what do we have? Okay, we are told about the velocity. Okay, now for my data, I'm going to have the VI, which is equal to because it's eastward, is going to be positive 20 meters per second. The mass is what? 1100 kg. Okay, now the force, a retarding force, which is in the opposite direction. Okay, 600 negative, and the change in velocity occurs over time interval of what? Of 12 seconds. Now what are we asked to get? Calculate the change in momentum. Okay, the change in momentum is what we are asked to find. We are asked to find the change in momentum. Okay, now how do we get this? We come to our formula of what? Newton's second law. Apply Newton's second law in terms of momentum. This is going to be change in momentum over change in time. So this is going to be negative 600 is equal to the change in momentum over the time interval of 12 seconds. So this is going to be 12, and then we cross multiply. The change in momentum is going to be equal to this is going to be equal to negative 600 times 12. This is going to be negative 7,200 kg meter per second. So the change in momentum is equal to 7,200 kg meter per second. In which direction? Westward, in the opposite direction, which is westward. Okay, which is westward. Now let us do example 2. Let us come to do example 2. Now for example 2, what do we have? A soccer player. I've got a soccer player kicks a ball which is moving towards him with a force of 120 newtons. His foot is in contact with the ball for 2.4 seconds. Determine the change in momentum of the ball. Okay, of the ball, the change in momentum of the ball. Okay, so now let us collect our data here. I would say we've got what? So the force. Okay, we need to indicate the direction first. We say what? Towards. It's positive, meaning away is going to be negative, away from the player and towards the player. Now F net. Okay, now a soccer player kicks the ball which is moving towards him with a force of 120 newton. It means the force will be exerted in the opposite direction, 120 newtons. His foot is in contact with the ball for 2.4 seconds. Determine the change in momentum. So this one is the same as the example 1. Okay, now F net, we say F net is equal to the change in momentum over the change in time. Okay, so we substitute negative 120, which is equals to change in momentum over 2.4. We cross multiply. The change in momentum is going to be equal to, when multiplying the two, this is going to be negative 120 multiplied by 2.4. The answer is negative 288. Negative 288 kg meter per second. Now the change in momentum is going to be equal to 288 kg meter per second away from the player. Away from the player. Okay. Away from the player. Now let us now check example 3. Let us now check example 3. Okay. Now with our example 3, what do we have? In a strongman competition, a competitor pulls a 5,000 kg truck with an average net horizontal force of 2,000 newtons. This increases the truck's velocity from 1 meters per second to 3 meters per second down the road. How long did it take the strong man to change the truck's momentum? How long? Now they want to get what? They want to get the time. Okay, so here we want to get what? We want to get the time. So how can we do this one? Now let us say A. For A, what data do we have? Okay, now we know that the mass of the truck is what? It's 5,000 kg. The initial velocity, okay, the direction, this one is going to be down the road, okay, it's positive, so it's going to be positive 1 meter per second. VF is going to be 3 meter per second. It is also positive. Okay, now they said pulls. It means the force is in the same direction as what? Is in the same direction as the velocity. So the net force is equals to 2,000 Newton. It is also positive. Okay, now we can say, answering this, we can say F net is equal to the change in momentum over change in time. Okay, but we know that the change in momentum is what? The change in momentum is also m into Vf minus Vi over the change in time. Okay, we know that the force is what? The force is 2000. Okay, the mass is what? The mass is 5000 into what is Vf? Vf is 3 minus 1, okay, which is Vi there, and we're looking for what? We're looking for change in time. Okay, so we just cross multiply here. So the change in time is going to be 5000 into 3 minus 1 3 minus 1 all over 2000. Now the answer is going to be 5000 into 3 minus into 1 and close bracket and then divide by 2000. The answer is going to be 5 what? 5 seconds. So it only took this strong man 5 seconds to pull this truck from 1 meters per second to 3 meters per second, to change its velocity from 1 meters per second to 3 meters per second. Okay, now let us look at B, the next question. Another competitor pulled the truck with a force of 3,200 newtons. This also increases the truck's velocity from 1 meters per second to 3 meters per second down the road. How long does it take this competitor to change the truck's momentum? Okay, let's just divide this page into 2. Okay, let us answer B here. Let's say this is going to be B. Okay, for B, you're gonna say, okay, F net is still equals to changing momentum over changing time. Okay, but now F net is equal to what? M Vf minus Vi all over the change in time. Now the force is now 3,200. The mass is still the same because it is still the same truck. Okay, also what to call the velocities are still the same, 3 minus 1 all over the change in time. We cross multiply. The change in time is going to be equal to 5,000 3 minus 1 all over 3,200. So 3,200, there we have it there. Now it took this Strongman 3,125 seconds. Okay, good. I hope you now understand how to apply Newton's second law in terms of momentum. Now let us do the impulse. Let us do the impulse. The impulse often the impulse. Now what is actually the impulse? Okay, the impulse is the product of the resultant force acting on an object and the time the resultant force acts on the object. That one is what is the impulse. So impulse is equal to what? Is equal to the resultant force F net times the change in time. The units can be Newton second, meaning you know the force, the units for force is Newton. The unit for time is second. Okay, but the other units that we can use is kg meter per second. Okay, I will show you where this one comes from. Okay, now impulse is what? Impulse is a vector quantity, and the impulse on an object has the magnitude, this magnitude. Okay, you have to multiply the two to get the impulse of an object, and has the same direction as the force acting on the object, because we said there it is what? It is a vector quantity. The magnitude of the impulse, you get it in this way. Okay, good. We also have the impulse momentum theorem. The impulse momentum theorem. Where is the impulse momentum theorem coming from? From Newton's second law. If we cross multiply the two, we're gonna have net force times the changing moment. F net times the changing time, which is equal to the changing momentum. Okay, now which becomes F net times changing time equals to, which is this represent the changing momentum, because the changing velocity is Vf minus Vi. The changing velocity is equal to Vf minus Vi, which is what? Which is the changing momentum. So what is this? I just explained there that this is what? This is equal to the impulse. So this is the impulse. So the impulse is equal to the change in the changing momentum. But what are the units for the changing momentum? It is kg meter per second. Okay, so the other units for the impulse can be kg meter per second. Example 1. Okay, now applying what? The impulse momentum theorem. A 500-gram rubber ball hits a wall at 20 meters per second and bounces back, making a contact with the wall for 0.1 seconds. The momentum of the ball changes by 15 kg meter per second. Take the initial velocity as positive. Calculate the magnitude and direction of the impulse that the wall exerts on the ball. Okay, good. Now let us say the original direction is what? Let us take the original direction as positive. Okay, it's positive. Now what do we have in this case? Okay, we are told the momentum of the ball changes by, it means we are told that the ball bounces back. Now the change in momentum will be in the opposite direction. This is going to be negative 15 kg meter per second. Okay, we also have what? We also have Vi, which is positive. This one is negative because it's in the opposite direction. This one hits the wall, the original direction, 20 meters per second. And the change in time, it is in contact with the wall for 0.1 second. Okay, the mass of the ball, it's 500 divided by what? By 1000. This is going to give us 0.5 kg. Now we need to convert that gram, because the unit that we use for mass is kg, kilogram. Okay, good. Now calculate the magnitude and direction of the impulse that the wall exerts on the ball. Okay, good. But we know that the F net change in time, which is the impulse, is equal to what? Is equal to the change in momentum. Now we are applying what? We are applying the impulse momentum theorem. Now this is going to be equal to negative 15 kg meter per second. Now the impulse the impulse, which is changing time, is going to be 15 kg meter per second when in the or away from the wall. I was gonna say in the opposite direction. Let us use away from the wall. That will be what? That will be the impulse of this rubber ball. So good people, that will be the end of my lesson. Let us meet again on the next lesson, where we will be doing the principle of conservation of linear momentum. I thank you.